This FIP is Solar PID Reversal Unit, supervised by Dr. Muhammad Ashraf. As we know, modern world is shifting towards solar power as other sources that are being used to generate power are fossil fuels, and we know that as the world population is increasing rapidly and fossil fuels are decreasing drastically, so the world is moving towards renewable energies. But using solar panels, an issue arises, and that is of PID. PID means potential induced degradation. This phenomena is natural and it will occur at any cost of our project. At any cost. Our project here deals with this issue by flowing reverse current through panels. This increases the lifetime of the panel. Now let's move towards the demo of the project. This circuit is of high voltage constant current source. As the name suggests, this current gives a constant supply of current through the solar panel. The circuit specifications include 300 volt operating voltage and we obtain 10 milliampere current. Zener diode helps keeping the voltage fixed. So here we wanted to keep fixed voltage across the resistor R1, as we can see. So the fixed voltage is ensured by the Zener present here. The values of the components are designed according to the specifications. So now let's just run the circuit. Firstly, the load value is set to 20 ohms. And now we will see the results. So here we can see the current is 10.5 amperes and we have fixed the voltage at across R1 is 3.44. So now we will change the load value and see again that what happens. Now the load value is 500 ohms and still the current remains at 10.4 milliampere and the voltage at across R1 is 3.44 ohms. So finally, even if now even if we still this we detach the load, or even if the load is not attached, still the circuit works fine according to our desire. So it shows that it is independent of the load, no matter what the value, or even if there is no load, still it is showing 10.5 milliamperes and the voltage across R1 is fixed at 3.44. Here is another circuit. This is a boost converter which is boosting the voltage from 12 to 1000 volts. This circuit has two modes. In mode 1, when the switch, here we have used an electronic switch, this is called as MOSFET. So when the switch is closed, it is mode 1. In this, when the switch gets closed, only the circuit that remains is source and an inductor. So the inductor starts getting charged. And now when the switch gets open, this goes in mode 2. So in mode 2, the circuit that remains is RLC circuit. And since we know that the inductor was already charged in mode 1, so now again this since the source is also present, so it will again charge the inductor. So they will add up and they will move towards the capacitor. So this is how, and it will again add up and more towards the capacitor, and this is how the voltage is boosted. So now we will see the results. Here we are opening the scope 1. Here you can see this is the 12 volt input. This graph shows. So now moving towards the output, it should show 1000 volts. Yes, we can see it has started and it has got a constant voltage of 1000 volts. So the circuit is working properly. Thank you very much.